Hey, good afternoon. How's everyone doing? Been a good week at DevOps World, Jenkins World this week? All right. Well, we appreciate you coming to our talk today, ClubB Score on EKS, Best Practices and Amazon EC2 Spot Instances. I'm presenting today with my colleague Derek Felska, who is a Senior Specialist Architect with Amazon EC2 Spot. And my name's Bill Garrett. I'm a Principal Solutions Architect with CloudBees. Some of you may know me also as Jenkins, because I've dressed as the butler the past few nights. A lot of folks asked me when I was dressed as Jenkins, like if I was an actor. Superman last night was an actor. Batman was an actor. Wonder Woman was an actress. You ask them, how do I get more mileage out of a highly scaled Jenkins system? They wouldn't know anything. But the butler is about to serve. First, though, just a review of what we got on tap. I'm going to have Derek go first. He's going to talk about Amazon EC2 Spot Instances, what they are, what are some of the best practices, and what are some of the options you have for getting maximum cost-effective usage out of them. Then I'm going to talk about how you take some of the best practices with ClubB Core and press the easy button in EKS using our relatively new QuickStart integration. I'll give you a demo of ClubB Core running with the QuickStart and using Spot instances. And we'll wrap that up with some Q&A at the end. So Derek, I'll pass it over to you to talk about EC2 Spot.
Great. So thanks, everybody. Nice to be here. So as Bill mentioned, I'm a solutions architect with Amazon, and I specialize in EC2 Spot. So I'm here to talk to you about what I love, Spot instances. So in the room, everybody, how many have you heard of Amazon EC2 instances? Hopefully a few of you. All right, good. I don't have to spend too much time setting this up. Just do a quick refresher on them, though. So we have basically 3 different ways that you can purchase EC2 instances. There's on-demand, which is exactly what it sounds like. You ask for an instance, you get it, and you pay by the second. When you're done, you turn it off, and the billing stops. So that's option 1. We have a second option for getting EC2 instances, which are called reserved instances. So in exchange for you making a commitment to AWS for either 1 year or 3 years and getting a pretty nice discount in the process, we will commit back to you to give you that discount. And depending on the type of reserved instance you buy, you'll also get guaranteed access to that capacity. There are a few different options there, but that is certainly one of them. And then there's this third option that we have called EC2 Spot. How many of you have heard of Spot? All right, good. So I'm going to make sure that everybody has the most current information in terms of how Spot works, and also just give you a quick overview of what they are, why we have them, and what they're good for. What are the best use cases for Spot? So what Spot is spare EC2 capacity. This is basically compute that's just sitting around doing nothing other than consuming energy. And so rather than have it do that and do nothing, we sell it to customers at up to 90% off of the on-demand price. Typically, we see that discount more in the 70% range, but there are certainly cases where it gets up to 90%. So what's the catch? There's a catch, of course, right? So the catch is that with 2 minutes notification, we can actually take that instance back because perhaps an on-demand customer would like to use that capacity, and we're actually running low on instances in that particular capacity pool. And I'll talk about what those pools are coming up. So 2 minutes, we can tell you the instance will be notified. You'll get a notification in your account as well via CloudWatch, at which point you've got a couple minutes in order to kind of clean things up and do whatever you need to do to have that instance prepare to shut down. Doesn't happen nearly as much as you might think. In fact, 95% of the time, Spot instances are terminated by the customer, meaning they finished doing whatever they were doing and they shut them off on their own, which means about 5% or even a little bit less of the time an instance is actually taken back because we need it for capacity reasons. All right, so just want to give you just an idea about how much capacity we have. We have a lot. So this is a great customer example of ours, Western Digital. So they actually used Spot instances and scaled to well over 1 million vCPUs or cores, and did it to basically simulate a bunch of stuff with how the hard drives work and how they were going to position the head and voltages and all this kind of stuff. And they were able to do this, what would have taken them 20 days, in their existing data center, they were able to do it in 8 hours using Spot instances because, number one, of the cost savings that they can get, up to 90% off, remember, and also because of the scale. They were able to do this in a massively parallel way and scale to, like I said, well over 1 million cores. And this is not an isolated case. We have lots and lots of customers that are doing this on a very regular basis, doing these types of workloads using Spot instances. So it's a very powerful tool in order to be able to get a lot of work done and do it in a very effective cost point or price point. All right, clicker, are we working? There we go. All right, so let's just talk quickly about some basics with Spot. So if there's one thing that you walk out of this room with today, I want you to remember this. If you ever heard the term bidding, erase it from your mind. That's gone. We got rid of bidding in 2017. So in 2017, we basically eliminated bidding and we went to a long-term market-based pricing model. And these fluctuate very little over the course of a day or even a week. In fact, usually just a few percentage points on any given day. And so this means that you don't really need to worry about losing a Spot instance because another customer decided they were willing to pay more than you. So that is gone. That does not happen anymore. And Spot instances are only terminated now because of capacity needs. So just remember that, please. And don't ever use that term bidding again. Try to remove it from your mind. We hear it all the time. It's a lot of misinformation still out there. So I take every opportunity that I can in order to make sure that customers have the current information about how Spot works. So you pay whatever the current market price is. And if you don't set a maximum price, and a maximum price is basically the maximum that you're willing to pay. And we suggest 99.9% of the time, don't bother setting a price. It's going to be at about that 60 to 70% off the on-demand price anyway. Just leave it blank. If you leave it blank, it defaults to the on-demand price. Okay? All right, so got that covered. Hopefully that all makes sense. And as I said, we don't do interruptions because of any pricing, anything related to pricing. Yes, sir? If you don't set a price, it defaults to the on-demand price.
Let's say I set a price at the reserved instance price.
Which would be about 50% off, something like that. Yeah, so if like I said, you will always pay whatever the market price is. You will never pay anything more than that. So whatever the price is at the time the instance is running is what you pay. So if you set your maximum price higher, that's not what you're going to pay. Does that make sense? Yeah. Okay, excellent. So just to give you a sense of the types of customers that are using Spot today, so it's a very real thing used by a lot of different customers. I'm going to actually give you a couple very specific examples, but just to give you a sense, they're used by customers like Pinterest, by Zillow, Uber, lots of use in media and entertainment, lots of use in research as well. So you can see there's a lot of different places where customers are using Spot instances and using them successfully. And now I'm going to talk a little bit about how we actually do that. Clicker, clicker, come on, clicker. So these are some of the integrations that we have with Spot instances today. Easy to use, so it works natively with AutoScaling, with services like Batch, Amazon EMR, which is our big data, our Hadoop offering, and a lot of other services as well. And we also have integrations with our container services like ECS, EKS, and as well. And then, of course, Jenkins. It works well with Jenkins and a lot of the other sort of CI/CD tools that are out there as well. And Bill is going to do a very specific demo around this with their CloudBees core platform as well at the end of the session. So you'll get a chance to see them in action. Mind clicking for me? Thank you. Can you just click it like 3 or 4 times here until this builds out? One more time. One more time. There we go. All right. So I want to explain to you what spot pools are. So spot pools are basically every single one of those orange boxes that you see on that screen is an independent pool of spot capacity. One orange box has absolutely nothing to do with another orange box. So remember that. So when we talk about getting Spot instances and using them, the strategy that we talk about for customers to be successful is to diversify. So here's what I mean when I say diversify. So let's say that your application, your workload is let's say it's a stateless web application. This is a great use case for Spot. You're accustomed to using the C4 2XL instance. So you're probably going to say, all right, I want to go across availability zone 1A, which is there at the top, 1B, and 1C. So if you take those instances and just go across those 3 availability zones, you've already got some diversification happening. You've got 3 Spot pools that you're already using. But let's not stop there. Let's also say that your application, your workload is accustomed to just needing compute, right? You don't really care so much about memory. That's why you've chosen the C instance family. So let's use the M's and the R's as well. They've got more memory than you need, but you're getting a big discount using Spot. So let's add those to the pool as well. So by doing that, now suddenly we've got 9 pools of Spot capacity because we've done, I'm sorry, 6, yeah, 9, 3, 6, yep, okay, I can do math. So we've got 9 pools of Spot capacity. Then let's go one step further. Let's say that you're using the C4. Well, let's add the C5 and the M5 and the R5. So you get the point here. I'm sort of adding and keep adding more and more options for my application to use. And what this does is it reduces blast radius. So if you were to have one of those pools that started to have some interruptions occurring, it's not happening in the other pools at the same time. So that's how we actually reduce the impact of an interruption on our overall workload. So that's what we consider to be one of our best practices. And it allows you to get capacity across a large number of different pools and really make it so that your application doesn't really see anything when you lose it. And if these are behind a load balancer, it's a stateless web application, you've got no problem anyway. You're probably already accustomed to adding and removing capacity because you're doing that because you're behind a load balancer, right? All right, so let's keep going. So this gives you kind of an example. So we have a couple different ways that you can request instances. We're going to talk about auto-scaling. But Spot Fleet has been around for a while. Both of them are valid ways to request instances. And you can see here, we're doing some diversification here. We want instances that have 2 CPUs. That's what we care about. But here's this nice long list of instance types that we've chosen in order to do that. OK? Come on, clicker. There we go. So let's talk about auto-scaling. So auto-scaling is a service that we have, and basically it's what we suggest to customers as the best way to request and maintain fleets of Spot, or of any kind of instance, not just Spot, but instances in general. So we were able to make some changes to auto-scaling late in 2018. And what that did, so before that, if you wanted to use Spot instances and on-demand instances at the same time, and even different instance types, so let's say an M5 and an M4 or whatever it was that you wanted to use, you actually had to create a separate auto-scaling group for each one of those. So if you wanted to use 4 different instance types and then add Spot into that, you could wind up with a lot of different auto-scaling groups to manage. Kind of a pain, right? So we took care of that, we fixed that, and now we can actually do this in a single auto-scaling group. Hopefully, that was the slide. So, wow, this clicker's going crazy. So you get the idea. This now allows us to basically combine different purchasing options and different instance types, sizes, generations, all in a single auto-scaling group, and we can basically do that all in one request and manage that as one single set of compute. So really powerful, and it also allows us to basically say, let me say that I'm going to do, I don't know, 30% of my auto-scaling group with on-demand. Let's say you wanted to start with a base capacity of 30 instances. So we know we're always going to use that base, so those on-demand instances would map hopefully back to some reserved instances that you purchased. So you're getting some nice cost savings there. And then we scale up from that point using either Spot or additional on-demand instances, depending on the characteristics of your workload. All right. Come on, clicker. All right, so what about those interruptions? I sort of mentioned it already. We actually have 95% of the time, customers terminate their own instances when they're using Spot. So pretty good, but it still happens, right? We still have interruptions that happen. So we get that notification that comes in. There's a couple different ways that we get them. We get them either via the instance metadata. So right on the instance itself, there's kind of like a web address that you can curl if you were running like a cron or something like that. So you're going to constantly be checking that, maybe every 5 seconds or so. You'll curl this web address. It's a 169 address. And you'll basically get a flag when that instance has been marked for termination, at which point that 2-minute timer starts. And hopefully you've got some processes in place. You've got some nice automation in there that's going to go ahead and maybe drain it from the load balancer or go ahead and checkpoint whatever job you're running off and save that data somewhere off the instance. So that's basically how interruptions work. There's additionally, relatively new, you can also get the notifications that a termination is about to happen via CloudWatch as well and take actions in the account. So you have 2 options. You can use one or both at the same time. You can take action on the instance as well as take action on something in the account. Maybe you're going to fire a Lambda off or something like that to do some kind of an action. So those are the way that our instances work. We also have a couple of additional behaviors besides terminate, again, relatively new. You can also have a stop-start functionality as part of Spot. There's certain cases where maybe that's useful. And there's also hibernate available as well now. So those are a couple additional options that are available in terms of being able to do that with Spot instances. All right. Sorry, guys. Let me just build this out. So, cattle not pets. We're talking DevOps here, right? So hopefully that's a term that a lot of folks have heard. We want to treat instances as ephemeral. We want to treat them as cattle. We don't want to name them. We don't want to take them to the vet when they get sick and get them and have them get well. Unfortunately, as cattle, when a cow gets sick, we replace it. So that's exactly how it works with these types of instances, and that's the best way to be successful using Spot instances as well. We just don't want to have to worry about snowflake instances out there. All right. Any questions here? All right, so I'm going to talk. Hey, yes.
Yeah, how does it decide which Spot instances to terminate? Is it like a first in, first out?
It's not first in, first out. We choose them in an arbitrary fashion. It's pretty much random, yes. Yeah, and that's the fairest way to do it. Yep, good question. All right, so real quick, I just want to talk about a couple of use cases. So containers are a great use case for Spot as well if you're running, and Bill's going to talk about EKS here a little bit. So containers are a perfect use case for Spot. By nature, by definition, most containers are relatively short-lived tasks. They typically don't run for more than 2 minutes. If they do, then you have to do some other things in order to use them with Spot. But by definition, containers are great. So containers plus Spot can equal a really, really great set of infrastructure to run on, and you can get some really, really good cost savings. Skyscanner is a company based out of the UK. They're sort of like the Expedia of the UK. They sort of do airfare shopping and that kind of stuff, and they extensively use Spot to run their front-end infrastructure, and they do that on containers. So great use case here. We got one more, I think. Yep, so this is also a good use case. So Lyft, based here in San Francisco actually, is also a huge user of Spot, and they do that extensively in their CI/CD pipeline process as well, and they do that with Jenkins. So another great use case for Spot. There's a plugin that's available that you can actually install on your Jenkins server, and it will actually launch Spot instances on your behalf in order to run software builds or unit testing or whatever it is that you're doing with your Jenkins server. So with that, I'm going to hand it over to Bill. Thanks.
Yeah, thanks, Derek. Hey, can I grab that lavalier microphone?
You got it.
Thank you. Yeah, so ClubB Score is a product that we sell designed to help solve scalability challenges around using Jenkins. And when I say scalability, I don't just mean having enough servers to throw at the problem, because scale problems appear in a number of other ways. And these are the types of things that we hear from tons of people that we talk to, right? Is that when you're operating at scale,
what often happens is developers go wild with practices, right? They do things that are harmful to their own development. They do things that are contrary to, say, the security needs of the company. Right? These are challenges when you have a highly scaled team that's all using a Jenkins system. Right? Another thing we hear is that it's hard to onboard new teams, right? Because again, a highly scaled system, you have thousands of people using it. That probably means you have dozens of new people coming on every week. How do you handle that? And of course, with all these teams out there, right? It's not just like, hey, 2 teams are sharing a small Jenkins server. It's 200 teams or 2,000 teams even. And how do you manage all the configurations and put some consistency across them, right? So those are all the kinds of scalability challenges we solve, in addition to helping you bring enough servers to bear on the challenge. And of course, the server scalability becomes very easy when you're using a platform like AWS. So what we do here with, there we go. I just want to give you a quick overview of the architecture of the CloudBees core software. You've probably seen a lot about this elsewhere at this week's DevOps World, Jenkins World, so I won't belabor it. Just wanted to talk about a couple of the components there. You have the CloudBees Core Operations Center, which is acting as a master of masters. And then you have individual masters that can be used by different teams or projects or apps. You know, my simple diagram here, I'm just drawing 2, but that could be 2 or 5 or 20 or 3,000. It really does scale pretty big, right? Now, when we talk about deploying this on AWS, just a few months ago, we introduced a really nifty AWS QuickStart integration. Right, so this ties very deeply into AWS and Amazon's EKS service. It's built on top of CloudFormation technology and has a few Lambda functions in it. And basically, it's a turnkey deployment method to get CloudBees Core running inside Amazon's EKS. There's even 3 options for how to deploy it. Number 1, if you're a new customer to Amazon, sign up and take the first option, and it will create a new VPC, virtual private cloud for you, and we'll tilt up an EKS instance in it, and then we'll deploy Core into that EKS. Option 2, if you're already an Amazon customer, you already have a VPC, you already have your routing rules set up and stuff like that, great. Point us at it, and we'll just set up an EKS cluster and then deploy Core into that. Or finally, third option, if you're already running workloads in a Kubernetes cluster and you just want us to be in a different namespace with new nodes, fine, take that option too, and we can deploy into that environment. And no matter which one of these you pick, it takes about 45 minutes to deploy it. And most of that time is going to be spent with the different functions running and instances tilting up and getting the configuration. The work that you do as an administrator takes all of about 5 minutes, and it's done through some pretty nifty web forms. So one of the other cool things about this Quick Start is that we embed a lot of best practices that might otherwise take a lot of time and thinking to get to. And I've got a bunch of them listed up on the screen here along with a pretty dense diagram. So I want to just talk through a few of them. The first is if you look at these 3 columns here, right, those are 3 different availability zones that are available in the region, right? The reason that you would want to span your components across availability zones is for fault tolerance. So that if a server goes down or if an entire zone goes down, there's other resources already online that your services can be rescheduled onto. And helping with the ability to move services across AZs is Amazon's EFS, Extensible File System. Elastic File System, excuse me. I've heard a lot of EFSs this week. Yeah. EFS is available across all the zones, right? And that's important for services like the Jenkins masters running in Kubernetes because they're attached to a Kubernetes Persistent Volume Claim, or PVC. So if a master goes down or a whole node goes down in one AZ and pops up in the other, EFS allows us to make that VPC available there as well. Or PVC, excuse me. Too many acronyms. This is also tied into AutoScaling Groups, right? So you can set a minimum, a maximum, and a preferred number of nodes. And of course, you can, as an administrator, you can also change those numbers on the fly, and the system will grow automatically. In addition to the kind of the separation here by columns, where I have different availability zones, we also set up 3 different partitions in your cluster. And those are kind of shown here across the horizontal, right? So what we're doing first is we're giving you a partition where you put your masters, a partition where you put your agents on durable nodes, and then a partition where you have spot nodes. Spot nodes are where you might want to put agents also. The first idea is that you separate your masters from all your agents because they have different life cycles. Masters are long-lived, right? Once you create a master, you want that master to be available probably for months, if not years. Whereas an agent, you only want the agent to be available for the space of one job. Now, you could, of course, have an agent that persists for a long time. Some people still do that. The reason we recommend against that as a best practice is actually twofold. Number one, because these agents are coming from containers, right? They're coming from templates or from images. They're very easy to tilt up. It takes like a second to provision a new agent. So there's no penalty to tearing them down and setting them back up when you need them. But those benefits are twofold. Number one is that it's a pristine environment every time because the description of a template is immutable. So you don't have to worry that, hey, when I do run number n, that there's some garbage file left over from run number n-1 of the same job that's going to pollute the results and give me false positives or false negatives. The second benefit is for optimal usage of your resources, right? Because if you have agents that are sitting around, persistent agents doing nothing, they're taking up resources in your cluster, right? They have claims on CPU time. They have claims on RAM in your Kubernetes worker nodes. That means that if other people are trying to provision agents that actually do work, you're going to have to hit the AutoScaling group. It's going to have to add more nodes. And that's going to drive up your AWS bill unnecessarily. No offense, Derek. Yeah, and the spot instances are there too. As Derek was pointing out, some people might think that spot instances are like, ooh, scary. They might get revoked on me. The fact is they don't, but there is a small chance of it. So that's why we give you two different partitions. So if you choose, you can say, hey, here's a workload that absolutely, positively must get done, right? Put that in a persistent partition, right? If it's one where you can say, hey, I can take a few in 100 chance it might get ripped away and I rerun the job, but I want to save a lot of money, go ahead and put that in the spot instances pool. Right? And by the way, in the spot instances pool, or the spot instances partition, we support multiple spot pools like Derek was talking about, right? So you have machines of different profiles available, so that if one profile is in high demand at Amazon, it gets ripped away from you. There's other resource types that are already there available. And again, we make this as close to pressing the easy button as possible when you go through the QuickStart interface. Okay, so a lot of information coming at you here, but I think the next thing we want to do is give you a demo. So I'll hop back up here to the stage, and we'll get some real software going. Yeah, so I think the question was if you have a job that's running on a spot instance and the spot instance is revoked in the middle of the job, right? So that's a case where you start to get into the pipeline foo, if you will, inside Jenkins. There are different ways to code your pipelines for reliability and fault tolerance. But basically, yeah, the way that pipelines are managed in Jenkins is designed to be resilient against different kinds of failures, including the ability to run something again if the machine goes down.
But if the spot instance gets taken back for longer use, does the master recognize that it just lost that load and move it somewhere else, or do you have to wait for it to restart, or do you have to restart it yourself?
So the master will restart the lost work, but it's not going to be blocked on waiting for a specific instance to come back. Right, it's just going to, assuming that you label the agents with flexible labels, it will simply provision another copy of the same type of agent on whatever resource is available and restart that step of your pipeline there. Okay, cool.
And the key here is to make sure you're checkpointing stuff along the way.
Right, yep. That's your pipeline sucks.
Yep, exactly.
All right, so I've got my Amazon console up here taking a look at the instances in my cluster. I've got several different instance types here, right? Some of these, I basically built this out so I have 2, 2, and 2. I have 2 worker nodes from my masters partition, 2 from my permanent agents partition, and 2 from my spot instance partition. I also have a last single machine here called the Bastion host. This is the one that as an administrator I'm going to be able to SSH into and run Kubernetes commands like kubectl for some of what I'm going to do. Right? If I take a look over here at the application level though, this is my CloudBees core operations center. We just call it the OC. I'm going to call it the OC for today. This is a relatively small cluster, and I've only got 3 different team masters in here. Right, this one I've got a few demos in that I'll run in a moment. This one I've got actually nothing in here right now. But I've got these 3 masters going, and if I take a look over at my command line, let me get logged in here. Let's take a look at which pods are available. So this is a look at what's running in my system right now from the kubectl level. So I have the Jenkins Operations Center here, and I have 1 pod for each of the masters that are running. Right now there's no pods for agents because the agents are all provisioned on demand inside Jenkins. What I'm going to do though before I actually run a job is I'm going to give you an example of how fault tolerant the system is. Right, we talk about what happens if a container or pod fails, how it gets restarted. Well, let's look at what happens if an entire machine gets torched. Right, so that's why I brought up this description here, because I want to see, hey, there's 2 of these masters that I know are on a node, same node 108, and I know there's nothing going on in those masters right now. So I'm going to go back into the AWS console, and I'm going to find that 108 machine, and I'm going to kill it. Going to terminate an entire server. Right, this is something that people usually wouldn't be too happy about doing with a production DevOps system. I mean, I've essentially done the equivalent of pulled the power plug out of a physical server and then pushed it out the window of my 8th floor office. Right? Now, what's going to happen though, first of all, is AWS with its AutoScaling group is going to replace that server, because I've told it I want 2, and now it only sees 1, so it's going to spin up another one as soon as this one finishes falling out my 8th story window. And then EKS, with its fault tolerance, is going to reschedule all the pods that were lost when that server went down on the new server. So that's going to take a little while, right? If I go show you now this server, right? This server is out to lunch, or I should say that this master in this pod is out to lunch because it's waiting for new resources to spin up. There is going to be a gap of a few minutes here. But meanwhile, I've still got the operations center. I've still got the other masters, right? There's the blast radius is limited because it's only 1 server that went down. So if I take a look in here, right, at the got a couple of different jobs here. One that's designed to build on regular agents. One that's designed to build on agents in the spot instance partition. I want to show you what's going on here with how you utilize spot agents from within a Jenkins pipeline. Now, I'll admit there's one thing here I'm going to show you that's not a best practice, which is that I have pipeline code stored right in the UI. The best practice would actually be to put this up in a separate SCM tool like github.com. I stuck it in here, honestly, because it's fewer dang things to click around for the purpose of giving a demo. But if I was doing this for real, this would totally be in github.com right now. But I can show you what's happening here inside this pipeline script. We're giving a spec here for the pod template. This is the environment that the work in this build is going to run in. Right? We're just pulling containers off of Docker Hub, right? But down here we also have this these 2 entries called node selector and toleration. These are entries that tell Kubernetes where we want to schedule this pod. The partition statement there says spot agents. That's telling it we want this to get put in the spot partition. And then furthermore, I added a toleration because remember what I said about there are some workloads that you just don't want to take even a small risk with the spot agents for. So at the Kubernetes level, what I did is I put a taint on all the nodes in that partition. So nothing is going to get put there unless it says, hey, I can tolerate the taint. So that's why in addition to specifying the partition, I also had to put a toleration for the spot agents. Right? That means that this pipeline, which just does a Maven build of an open source project, is actually going to run in those spot instances. So let me go back up here and get this kicked off. Now, just to show you where it's running, let me take a look back down here. Excuse me. See if I can make this a little bit bigger for you all. So if we take a look at the pods that are running right now, we see that we have a Maven pod running, and this is on node 10.0.64.71. And if I go grab my other kubectl command that prints out which node is in which partition, right, that .71 box is in the Spot agent partition. Right, and that job's going to take a few more minutes as it spins. That's just what it is. One other thing I wanted to show you is back over here in the interface. By the way, the reason I'm not going through the actual process of deploying a new cluster with this AWS QuickStart is it does take about 45 minutes. I mean, I could spend like 5 minutes walking you through all the instructions, but then it's going to take like another 40 minutes as everything gets tilted up. It's not really the wise use of time here. But I want to show you how you could do something like take the AutoScaling group for the Spot agents and make it bigger. Right, so if I pick the right group here, I go in and edit it. Right. Remember before I said that there's multiple instance types? I picked 4. That's this list right here. These are the 4 different instance types, 4 different Spot node pools. I can add more. I can take them away. I can change which types they are. But down here, I can also say, look, I want to have more Spot nodes available. Right. I don't want to wait for the time it takes to even spin them up inside an ASG. Right, so I get that going right now. Take a look back over at my instances page, and Shazam, look at all this stuff going on here. I have all these new Kubernetes worker nodes spinning up for me right away. Yeah, go ahead.
Real quick question, while those are spinning, what are you doing for the Spot price? Are you just giving it just below the EC2 price and letting it price at market? How does that decide the price you're getting for those spots?
Well, the price that you get from Spot is the current market price.
Right.
That's all you're going to.
But what do you have to, so you don't put in any numbers anymore, you just say, give me Spot.
Give me Spot, whatever the current market price is, and that's typically.
Are there ways to project that for the people who are going to ask? Oh,
I mean, you basically do the same thing somewhere, you know, so we can show you the tab.
Yeah.
average that out over time after that, right?
Like I said, on average, it's usually in the 60 to 70, closer to 70%.
Yeah. In fact, what I skipped over talking about is this advertisement that's up here on the top of my window when I was over in the AutoScaling group list. It's like, hey, so over here, Amazon is letting me know that I can use Spot instances and save up to 90% off of my reserved instances and on-demand instances. So, yeah, kind of apropos.
We didn't plan that.
Yeah, I certainly don't have control over his ads. Yeah, so you can see I've already got all these instances up and running on the Spot node. And look at this up here. If you look in the first 3 items, I have a new master node running. So I'm back up to 2 copies of the master node that are running. And my interface is still showing me the information about the one I terminated a few minutes ago. In fact, if I go back down to my console, right, let's take a look at which machines I've got. Right, so now you can see I'm down to 2 masters, including the new one. And I've got 2 regular agent machines, and I've got 10 Spot agent machines. Yeah. Memo to self, go and delete those instances before the end of the day, otherwise my admin's going to scream at me, because even at 90% off, it can add up if you have a whole bunch of machines you don't need. Right? Meanwhile, let's take a look back at what's going on with this build. Looks like this build is just about done. Right? And as I showed before, this is running on the Spot instances. So again, it's a way to save a lot of money. Meanwhile, I can take a look back over here at this old node, the one that had failed, and it's back up. Right? And by the way, we were talking about what happens with Jenkins pipelines in the face of failure. If it's the agent that fails, the master will provision a new agent and rerun the half-lost step on that one. If it's the master that fails while jobs are running, while pipeline jobs are running, pipelines themselves are designed to be resistant to cross-failure. The completed work in the steps on the agent will wait to be able to reconnect to the master. And there are configurable timeouts there, but we're talking about things that default to like a day or something like that. So if this master went down while jobs were running, the jobs aren't going to fail. They're just going to wait for the master to come back up, and they'll report their completion then. And then the jobs will pick up and resume from that point. So to summarize, there's a bunch of resources that are available. There's a help page on getting started with EC2 Spot Instances. We got the URL for you there. There's also a plugin available for open source Jenkins. Right? What I showed here was ClubB Score. I'd love for you to use our ClubB Score enterprise software. But if you're still using enterprise Jenkins, if you're still using open source Jenkins, there's a really nicely featured plugin that Amazon's created to make it easy to pick and configure Spot instances from inside Jenkins. We've also put together a self-paced workshop with how to do CI and CD and test workloads with the Spot instances. So both the plugin to get you going as well as a little bit of a tutorial that you can consume. And then finally, we have the QuickStart information, the CloudBees QuickStart information. So if you'd like to read more information online, it's like a nice 25-page document that'll walk you through all the best practices I've talked about today and how we automate that process for you. And finally, if you have any questions, you're welcome to email one of us, felskad@amazon.com, bgarrett@cloudbees.com.
Just one real quick comment too
Sure.
about the workshops. So that's not the only workshop that's up there. If you just want to learn more about Spot in general, just EC2spotworkshops.com, and there's a whole bunch of self-guided workshops that you can go through on your own as well.
Okay. Yeah, thanks, Derek. And just one last thing for me is that while what I've talked about today has been CloudBees' Jenkins-based product, CloudBees Core, there's actually a lot of other products and services in the CloudBees suite to help you with all of your CD needs. I'm not going to talk about the rest of them today, but I welcome you to stop by our booth on the show floor and talk to me or one of my colleagues about any of these. Likewise, I know Amazon has many other products and services, and someone like Derek would be happy to help point you to the right place and resource for those. Thanks, everybody.
Thank you.
A couple more minutes here before we have to vacate the room. Were there any additional questions before we all have to go?